All right. So the next thing that we're going to do is 2.1, and it's called piggies and pools. And so we're going to be able to represent situations with different types of growth, compare models for situations that occur over time, and what type of situation can be modeled by a continuous graph, and when separate points are appropriate. What are the similarities and differences between arithmetic and a linear function? And can a geometric sequence be continuous? Okay, so all of this to say, right? All of this to say, this is what your goal is. Right. So as we're learning this, you're like, oh, now I can compare models. Oh, now I know what the difference is. Now I know what these things are. So that's why this is always going to be put right in front of you, right at the top of each of these lessons. Okay. So here's this question, and I'm thinking of you who called this a pretentious example, which still makes me giggle. Okay, so here we go. So my little sister Savannah is 3 years old. Oh my goodness. She has a piggy bank that she wants to fill. She started with 5 pennies, and each day when I come home from school, she's excited when I give her 3 pennies that are left over for my lunch money. Use a table and an equation to create a model for the number of pennies after day N. Okay, so here we go, guys. So the very first thing is I'm going to build a table. You guys all know that because Miss Johnson, she likes her tables. It makes the most sense. And it's just like a easy representation, not easy as in easy, but easy as in something that I know how to fill out, right? So this is this is like day N, right? And then this is how much money is in her piggy bank. And we'll put money in pennies, like in terms of number of pennies, because I don't want to have to keep track of decimals. Got it? Very good. I'm glad. The chat makes me happy, guys. Okay, so it says, okay, so my little sister, you guys all follow me so far on this? So what would I fill out on my table right now? What's something that I could fill out on my table right now? Okay.
I'm not sure, but maybe for the where it says n pennies, maybe put 5 pennies, because it says she started with 5 pennies.
Yes, so she starts off with 5 pennies, and this is where people get a little bit confused because they don't know if that means that that's day 1 or if that's day 0. And day 0 kind of sounds like really silly, right? Day 0, Miss Johnson, day 0. And actually, this is like a scientific term, day 0, patient 0, they'll call it sometimes. It's it's like your initial information. Okay. So let's see if they tell us. They say, my little sister, she has pennies, she started with 5 pennies, and each day when I come home, blah, 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 use a table and an equation to create a mathematical for the number of pennies in piggy bank on day N. So they didn't really give us a chance here to figure out if it's 0 or 1. I'm just going to tell you right now, either one makes sense. Does that make sense? So Ms. Johnson, what do you mean? Like it could be either one. So do you see how we could say she started off and that would be 0? Or we could say on day 1, there was 5. Does everybody see like how I could put both of those in there and both of those make sense? So I'm going to actually write it as 0 because that's how many days that's how many, how do I put this? Because we're actually counting how many days I've given my little sister 3 pennies, right? So I've given her 0 pennies on day 0. Does that make sense? Okay, so I'm just going to say, by the way, if you put a 1 here, it's not going to be like all wrong. Okay, and then I like to be very clear and say things like, and you can count 5 pennies as day 0. Okay, then what happens on day 1, then what happens on day 2, then what happens on day 3, and then what happens on day 4? What do I write here? What happens to day 1? Yeah, I add 3. So I'm actually not going to put 8. I am going to put 5 plus 3. And here, I'm not going to put whatever that number is. What am I going to put? Yeah, I'm going to put 5 plus 3 plus 3. Very good. For those of you who are trying and putting stuff out there, awesome. I need to write this down. Okay, so is everyone feeling a little bit more comfortable with what we're talking about here? Okay, the next one is going to be 5 plus 3. Oops. Plus 3 plus 3 plus 3, Miss Johnson. And here I'm going to trade this out for n days, Miss Johnson. So what would this be? So here's the question that I really want you to focus on right now. What is staying the same and what is changing? I'm going to say it again. What is staying the same and what is changing? So what needs to show up here and what needs to change? Okay. Very good. Yay, I'm so glad. We just started, by the way. Okay. I want to know how you thought about it too, hon, when you get a chance. Okay, someone said in the threes stays and what changes is the number of threes. Very good. So Miss Johnson, I see a bunch of threes here, but how many threes depends on what day is it. Very good. The 5 also stays the same. Really strong work. Very good. Okay, so then can you all think, don't write it in the chat. Do not write it in the chat. What am I going to put here? What do you think Miss Johnson's going to put right here in this row here to account for that? What do you think I should put there? Very strong words here, guys. Very good. Okay, you guys ready to try? And just put down what you think. It doesn't have to be perfect.
Doesn't n basically mean 4?
N basically means the number of days. So this is going to change. So in this case, if you wrote another line here, it would be 4. But I use N specifically.
Oh.
Good job. Keep going. Keep going. So what would I put here? So someone says, hey, Ms. Johnson, because the 5 is there the whole time, is it okay if I write my 5 here? Do you think it would appear there? Would it appear on that same thing over and over again? And people would be like, yeah, Ms. Johnson, it would be there. Very good. Now, someone said in the very, very beginning, they said something like, hey, Ms. Johnson, recursive would be +3, right? That would be the recursive rule, kind of, because you're just adding 3 to every single one, right? Do you guys all see that? Very good. Very, very good. And then someone a long time ago had my function in there. Okay, so what do you guys think? Now put it in the chat. What do you think what should I put right here? Right here. What should go right here? No, but for n. So another way to write this one would be 5 plus 3, right? I'm going to start collecting my 3s, right? So 5 plus, how many 3s did I get on this one? Oh, 2 3s. Okay. So 2 parentheses 3. Okay. And what would this be? How many 3s did I collect here? Can you rewrite this one for me? Rewrite this one for me. What would you write? Instead of 5 plus 2 times 3, what would you write here? 5 plus. Yeah, that's right. I'm going to clip that really quick. Here's my little guy. Here you are. Someone said, Miss Johnson, I think it's 5 plus 3 times 3. Where'd you go? Oops. Someone said this. Miss Johnson, I think it's 5 plus 3 times 3. Can I put this here and not make it look so messy? Well. Oh, come on, computer. Sorry, it's going to be stubborn. So this is going to be 3 parentheses 3. So what I want you to look for, y'all, while I fix this, what I want you to look for is what's staying the same here, what's changing here. What's staying the same here and what's changing here. What's staying the same here? What's staying the same? So then I'm going to keep the 5. What else is staying the same? What else is staying the same? Okay, get in there, get your answers in there. Don't let this go by. Yeah, the parentheses, Ms. Johnson, is still staying the same. So what's changing? What number here is changing? Describe where that number is, because you can't say the number because the number is changing. So you can't say the 3 because the 3 is actually changing, right? So Ms. Johnson, that 3 parentheses is staying the same. If I could highlight this, I would. Actually, I can. So let me do that. So I see, Ms. Johnson, this 5 is 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 this 5. All these 5s are exactly the same. Where did this 5 come from? In our context, what would that be? What's our context here? What does a 5 mean in our context? Yeah, it's the pennies your little sister started with, right? You guys remember when pennies used, like, you used to have 5 pennies and you're like, oh my gosh, I am rich. I am rich. Yeah, not anymore, right? Okay, so then yes, it has to do with our 5 pennies that she started with. Very good, 5 pennies. Okay, so then the next thing I'm going to move to is the other thing that stays the same is this 3, and this 3. These 3s all stay the same right here, right? This 3, these 3s all stay the same. What is the 3 in the context? What does the 3 mean in our context? Yes. Okay, out loud to the thing. Very good, Nayeli. Good job, Nayeli. Nayeli calls it the constant difference. Someone else said, hey, it's the number of pennies that I give to her. It's the number of pennies that I'm giving to my little sister, right? Exactly. So what's this that changes? What is this number that changes to 2, to 3, to whatever? Excuse me. Oh, thank you. What's this number? What is this 2, then 3 here? Nope. Look over here. Yeah, it's the days. So notice here, whatever this number was here, that number was there. Whatever this number was here, that was there. Wait, where, Ms. Johnson, I don't see this 1 here. I don't see a 1. I don't see the 1. It's there. I just didn't write it, right? Where's my cursor? 1 parentheses 3. Now I got to move over my little highlight guy because I moved him, right? Look, there he is. There's a 1. Miss Johnson, I don't see your 0. Well, okay, write it. It would be 5 plus 0 3s, right? See how it all matches? Yes. Very good. Okay, so then what goes in this empty little space here? For n days, what would go here? For n days, what would go right here in this spot? Yes, very good. More people, please. What goes in this n spot? What went in the right there? 1, 1, 0, 0, 2, 2, 3, 3. Where, Ashley, where won't it let you add a table? Onto OneNote or onto Desmos?
Oh no, onto OneNote. Like it doesn't show up that it gives me access.
Are you on your page?
Yeah.
Okay, so what I do is I click outside of this page. I click over here, and then I click insert table, and then go like this, like as many rows and columns as you want, right? So once I do that, it'll show up there. And if you're clicking here, it's because it's putting it behind this picture, maybe. That's the only thing I can think. Exactly, exactly, exactly. So someone said, Miss Johnson, you need to put an N here. Miss Johnson, why are you putting an N there? Because you guys said that number is reserved for the spot for the number of days. If I'm in N days, then it would be that. Yeah. So normally it's 0, 1, 2, 3, 4, but I changed it because I wanted to be able to write my rule. So now I wrote my rule, which someone else did, so I can clip that. Haha. Thank you for giving me my rule. So here's my explicit function. Why is this considered my explicit function? Why is this one considered my explicit function? Yeah, exactly. Someone said it's all you need, right? What do you mean it's all you need? Because if I said, hey, how much money does your little sister have at the end of the month? Well, you'd plug in 30 here, right? If I said, okay, well, how much money does she have after a whole year? Well, you'd plug in 365 right there, right? Explicit means it stands on its own. Recursive, if I was going to write about the recursive formula, how does, here, I'll ask you the question. For those of you who are still stuck on recursive and stuff, gosh, see if this works. Do you work now? Yeah, there it goes. So if I'm talking about the recursive function, you're answering the question, how does your function grow? Or how do you get the next term? Those are the two questions that your recursive function answers. So your recursive function looks like this. Someone typed it out for me. Thank you. Gracias. That I don't have to type it out myself. I pretend that I'm like all super lazy, but in reality, this is the equivalent of me being, hey, can you go put that up on the board so everyone else could see it? So you're doing it for me by typing it, and then I just do this. All right, there you go. So there's my recursive function. Do you see the difference between them? See, this one has f of n minus 1. I saw earlier someone put f of 5 plus n times 3, and no. Yeah, so if you put that, just fix it. That's wrong, right? Don't do that. So when you're doing the recursive function, you're literally looking for how does your function grow, or how do you get to the next term? Okay. I did my table, check. If I wanted to do my graph, I would do my graph like this. Now, here's the key thing, okay? You guys have been graphing for a really long time. And then so you expect certain things to happen when you graph. Sorry, I can't draw straight lines on my iPad. So just pretend these are straight lines. Oh, I can draw straight lines on my iPad. I should be. All right, just for fun, I'm going to show you that I can draw straight lines because you guys all judge me. Miss Johnson, she's that teacher that can't draw straight lines. I'm just kidding. You don't do that, I know. So I'm just going to draw my straight line here. Ooh, it's not even part of the line. Go up a little bit. Oh, it's not going to click where I want it to. Ah, that's good. It's not going to click where I want it to, but that's okay, right, guys? All right. So here goes my lines. Oh, that's pretty good, Miss Johnson. Okay. They are not perfect axes because they're not sitting like flush on top of those lines, but you guys all get what I'm doing. So on 0 days, so this is, I'm just going to make this like this. I'm going to go 1. This is 1. And this is 1. So I just show you my little scale by saying this is 1 and this is 1. On 0 days, she has 5 pennies. 1, 2, 3, 4, 5. Boom. Everybody okay with that? On day 1, she's got 8 pennies. On day 2, she has 11 pennies. Man, I did not leave enough room for my graph, but that's okay. You guys all see it? Now, some of you are like, Miss Johnson, connect the dots. You've been doing it since you were 4 years old. Do it now. So the answer is no. And I just kind of want to talk about this really quick, because if you get this, then we're pretty much done with the whole lesson. Okay. Why am I not going to connect the dots here? Yeah, don't connect the dots. Why am I not going to connect the dots? Okay, so it has to do with this context. Read my little context again. I'm talking about my little sister Savannah, and she's little and she has pennies in the piggy bank and she has 5. And then every day I bring her home 3 pennies, and N represents the number of days, and our y-axis is the how much money or how many pennies she has, right? Okay, why don't I connect the dots? Okay, if you don't know that, let's connect the dots and figure out why not. Well, yeah, let's connect the dots. Look at me drawing a straight line, kind of. Okay, so that pinkish purplish line that I just drew in represents this function 5 plus 3n. Everybody okay with that? Does it represent our context though? So simply put, hey, if that's true, then what does this point right here represent? What does that point represent? -1, right, comma 2. What does -1, comma 2 mean in our context, either in our table or from our story? What does that mean? Come on, y'all, you can do this. Okay, well, so day 1 would be -1. I mean, days would be -1, and pennies would be 2. Does day -1 make sense? Like if you asked me, hey, Miss Johnson, when's our next test? And I'm like, it's on the -3rd. Does that make sense? You guys would all say,
It happened 3 classes ago.
right? Oh my gosh, what happened, Miss Johnson? I missed it. Yeah. So day -3, day -1 technically doesn't make sense in this context. You are making sense of it. It's very good that you guys are making sense, because someone said, hey, Miss Johnson, doesn't it mean kind of like yesterday? Kind of, because if you're saying day 0 is today, then wouldn't day -1 be the day before? Yeah. Okay, so very good. Good. So now you all are thinking, okay, what does this point right here represent? Right there. I'm trying to unclick on it and I don't know why it's still highlighting it. So there it goes. There it goes. Kind of. What is that point right there? What does that mean? Yeah. What does day half and 6.5 pennies look like? What does day 0.5 and 6.5 mean? Does that make sense in this context? Day half. And some of you are like, yeah, Miss Johnson, like 12 hours, half of a day. Okay, fine. What does 6.5 pennies look like? Doesn't make sense, right? So does this make sense when I say we don't connect our dots? Okay, so we don't connect our dots because this point here doesn't make sense. 6.5 pennies doesn't make sense. Okay, so it doesn't make sense. What, Ms. Johnson? Yeah, no, it doesn't make sense. So far, so good. Okay, let's move on then. Okay, so very clear. Do not connect the dots. So today our job is to figure out, should we connect our dots today? That's one of our jobs. So our family has a small pool and for relaxing in the summer that holds 1,500 gallons of water. I decided to fill the pool for the summer. I was getting bored just standing there watching the water flow and began to think about mathematical model for the time it would take up to fill the pool while I was waiting. I literally do this. Like when I'm doing something and I'm like, oh my gosh, I could figure out the function of this, of what I'm doing right now. I do this. I know. That's who you got. You are stuck with me. Okay. I checked the flow of the hose and found that it was filling the pool at a rate of 2 gallons every minute. When I had 5 gallons of water in the pool, I started the timer. Use a table, a graph, and an equation to create a mathematical model for the number of gallons of water in T minutes. So the very first question I have for you is, Ms. Johnson is obviously going to use a table first. So I'm going to grab this table that I put up here earlier. So first I'm going to grab my table because that's her favorite thing to do. So she grabs her table. So the other question I have for you is, do you think that we should connect the dots for this problem? Do you think we should connect the dots for this problem? Okay, and that's not you. I don't necessarily want you to answer that question. I want you to be thinking about it as we fill this in. Okay, so here, I'm going to start you off with this table. So our table is going to have T minutes, T's in minutes. So I'll put min here, min. And then here, this is gallons of water, right? This is going to be gallons. Okay. So, so it says, let's see. You guys okay with this so far? Okay. So, at 0 minutes, when she starts the timer, how many gallons are in there right now? Don't tell me. Okay. And then how do you want to count? Do you want to count by minutes? Sure. 1, 2, 3, ... And then I'll put an N here, right? So here's what I want you to do. I want you to pause. I want you to fill this out. I want you to fill out the table. See if you can fill out the equation and give me a graph. The whole time you're thinking, does it make sense to connect my points? Okay. Okay, so how many gallons were there at 0? How many gallons were there at 0? Yes, it's 5. Very good. Okay. And how many gallons were there at 1 minute? Yeah, and I'm going to write it as 5 plus 2, right? You guys all know why, right? And then how many were there at 2 minutes? Exactly, 5 plus 2 plus 2, right? And then how many were there at 3 minutes? Man, Ms. Johnson, this equation looks exactly like this equation. I know. Okay. So then how many would there be at n minutes? And so again, the question is, what do you see as the same? What do you see as changing? And where does this n fit in? So give me that equation really quick. Is this? Shoot, how do I figure this out? Okay. Yeah, very good. So someone says, Ms. Johnson, I'm going to take a crack at it. It's 5 plus 2n. 5 plus 2n. Let's see. 5 plus 2 times 1. Yep. 5 plus 2 times 2. Yep. 5 plus 2 times 3. Yep. 5 plus 2 times continues on to 2n. So there's your equation. And I'm not going to write the recursive this time just because you'll notice that we'll move away from the recursive. Not forever, just for now. So there's my table. My graph is going to look like this, right? I'm just going to graph a quick one. It's going to go up by 5 again, 2, 3, 4, 5. And then it's going to go to here, and then here, and then here. So the question that I asked you guys, what do you think? Do I connect the dots? Do I connect the dots? Ooh, someone put my recursive in there. I'm going to snag that. Thank you very much. What do you guys think? Yes or no? Okay, you guys have to ask yourself the question. Does this point in between, does that point make sense? Does the point 1.5 comma 8, 1.5 comma 8? Does that make sense in this context? Does the point 1.5 minutes and 8 gallons of water, does that make sense? If I said, hey guys, give me 1.5 minutes, would that make sense? I need 1.5 minutes. Can I ask for 1.5 minutes? You guys would say yes or no. Uh-oh, we went silent. Yes, 1.5 minutes makes sense. How many seconds is 1.5 minutes? Does that exist? Everyone says yes. Does 8 gallons exist? Yes. Now think about as you fill it up. Like imagine you had like the perfect scale at the bottom of the pool that would measure how many gallons are in there. It doesn't go from 7 to 9 instantly, right? It goes 7 and then 7 and 1/10, 7.5, and then 8, and then it continues to 8.1 and so on and so forth. So for this one, we do connect the dots because that context does make sense. Now, I know some of you are confused and you're like, what the heck, Ms. Johnson? So notice I don't go on the negative side because of the negative minute doesn't make sense because she started the timer. There was no such thing as negative minutes, right? Some of you are thinking the minute before. Okay, for this one here, we connected it because 1.5 minutes makes sense. With 8 gallons made sense. Up here, 6.5 pennies doesn't make sense, right? It doesn't make sense. Here, this makes sense. 8 gallons, 1.5 minutes. Makes sense. So connect the dots, right? All right, so what I want you to do is I want you to try number 3 and number 4 and see if you can tell the difference between connecting the dots and not. And we'll show that in our next little thing.